step into the frame here. So yeah, my name is Ben. I've done a couple talks, mostly just filling in this month. This is just a hobby project I've been working on that is a work in progress. So yeah, if anyone wants to give a talk about a hobby or something you've been working on or some project that somehow vaguely involves Linux, go for it. But this has been because a few years ago I switched from NVIDIA cards because they had great Linux drivers. AMD open sourced the AMD GPU driver, so I switched over to doing AMD cards because then I don't have to deal with driver installations. The problem with doing that is that you don't end up with, you miss out on the OpenCL runtime. That was like a separate chunk that when you install the NVIDIA driver, you got OpenCL and all the compute stuff for CUDA, all those stuff, not all of it, but a lot of it was there as part of the driver bundle. But then when you go to AMD, it's just the driver, and Mesa then had support for games. So games run, but then what if I want to do OpenCL? The two things that I do is I like to just occasionally do some light benchmarking with Koenig Test Suite, if you guys have ever used that, which is kind of fun just to see where your system matches up. But then also Boink and Gridcoin stuff, so I like to do some science, when I'm not using my computer, let it crunch some numbers for Einstein at home, and then do a little cryptocurrency just fiddling on the side. I don't mind the currency, it's the payout from the processing. So the more you can process, the more you get paid, but your CPU is slow. So doing with the GPU means I can actually use my computer for stuff when I'm not playing games, just when I'm doing office stuff, and the GPU gets to do something, right? So it's just fun to have that option to leverage, some of the more, these days when you build a full-blown, desktop computer, has a lot of power, but you're not always using it. The problem though is because I'm on AMD, no OpenCL support. Mesa's, there's a few different vendors, but the Rust ICL thing can be a little slow and doesn't support every card. And if you look up how to do it, AMD says, oh, just install ROCm. Well, one does not simply just install ROCm, and that's what ROCm is. ROCm is AMD's software stack for compute. And it includes a lot of things. It's all the machine learning libraries, it's everything you need to run PyTorch.
For GPU.
For the GPU, yes, yeah. Yep. So it ties into, I think, what happened recently, and this is why the big thing with ROCm 7.0, because it's been around a few years, but ROCm 7.0 is different because it's a bunch of changes, they've reorganized a bunch of stuff, and now they've officially split the driver out. So it used to be you'd have like AMD GPU and AMD GPU Pro for Linux. Now you don't need Pro. You just use the one that's in the kernel. So if you're on kernel 5.14 and newer, you're probably fine. So anyway, so the scope of this presentation, so kind of who we're targeting, mostly package maintainers, users, if you're someone who has an OpenCL application you want to run, and you can't get it to talk to your card. And maybe some people who want to learn how to develop an OpenCL application on an AMD platform. You got to get it installed. Let's see. So what is ROCm? If you really want to read, I'm not going to read through this whole thing. This is AMD's description of their product. So this is kind of why I want to demystify it and talk about the packaging and talk about the minimal set of packages needed, because if you look at ROCm, you're like, oh, it's like 30 plus packages. It's a huge thing, but OpenCL has been around a long time. There's a lot of stuff that uses it. If that's all you want, it's a lot simpler to get that going. This covers, but ROCm covers more than just OpenCL. It covers, all the AI, machine learning, a lot of stuff to offload to the GPU, and it is the foundation for something like PyTorch. And in particular, the interesting thing is where it gets really confusing is HIP, the Heterogeneous Computing Interface for Portability, which I'm probably going to get in trouble for saying this, but it seems like their version of CUDA. It's a CUDA-style programming API. It's C, C++. But the idea is that it can, for their HIP libraries, and I'll go into detail later when I show the breakdown of the packages, if you write an application in HIP, or using the HIP platform, it'll actually work on NVIDIA as well. It can use NVIDIA cards as a backend. So now you have this idea, because right now, especially with cryptocurrency specifically, it's very NVIDIA-centric. So how do you get those people to be a little more, use different cards? And so migrating from CUDA to OpenCL, A, there's performance issues, and then B, it's a very different API. But if you go to HIP, and then it just use the backend, it's a lot faster. And they actually have a tool called Hipify, which can do some initial conversion of the CUDA code to HIP code, and then you kind of fix it, and it's a lot faster. So, supposedly. I wouldn't know, I'm not a programmer, but that's the claim. So if you guys want to try it, go for it. But before you can try it, you got to get it installed. So anyway, So that's tiny. Okay. So why did I start creating packages? Because AMD is bragging about it. There's Phoronix Test Suite. The Phoronix guy, he's been testing it. AMD, because like any company, there's a limit to how much they can support. It takes time, money, manpower to write it. So when they support Linux, they have released most of ROCm, or I think maybe all of it, but they say most of it, as open source. So you can go grab the source code and compile it. But they're limited in what they are willing to support. So GPU hardware, if you look at their compatibility matrix, they don't mention support for cards older than like the 7000 series, which seems odd because, and they actually say, oh, it's probably not going to work. Features are not going to be available. And I'm sitting there like, it's OpenCL. What do you mean? So, and then at the same time, distribution support. They're very limited in which versions of distributions. And again, the matrix has some it breaks it down. It says these are the official ones. Use the usual Red Hat, Ubuntu, Fedora, even Azure, the cloud platform for Microsoft. But if you're not on that list, well, how do you get it installed, right? Binary compatibility, when they release their pre-compiled binaries, it is not difficult in most distributions to take the Debian package, open it up, move stuff around, and repackage it for your distribution. But this then creates problems where is it really compatible with the dependencies on your system, and that can become a mess. If it works, great, but it can sometimes not work. And again, if you're in that situation, once you do that, if you find a problem, AMD is going to be like, well, no, that's you, that's not us. So, you're again still in that unsupported space, even if you're using their binaries. And also, it's open source. So once they say it's open source, well, I get to do whatever I want with it. That's there's always an element of that. Hey, why not? It's a hobby. And maybe you can make some tweaks to it. You can kind of configure it. So anyway, yeah. But for the goals for this, I want to kind of, I already identified target audience. I want to show kind of my process for building packages and kind of demystifying their setup, their CMake infrastructure. I want to demonstrate OpenCL compute. That's why I got this computer here. And I also want to address the open source, what I call the open source elephant in the room. That's going to get a bit opinionated. Try not to think too hard about it, but I just kind of wanted to share my challenge in dealing with what they call an open source build system, because I disagree. So here's an excerpt of their compatibility matrix. You can see, this is operating systems and kernels, Ubuntu, Red Hat, Oracle, Debian 12, even Rocky 9. And then they got they got layers to this. One of the things you'll notice, I have this is just a piece of it, but they have a lot of footnotes. Like, yes, this is supported, but there's caveats. And this is just like a small piece of it. It goes on. It's like a whole page. I'll pull that up. Actually, I'll pull it up later. I'll show you guys. We can dig through it once I'm through the presentation. And then also, if you want to use like regular GPUs, there's another page for that. I didn't copy that info in here because the page for using ROCm on desktop graphics cards has not been updated for ROCm 7. It's literally only says like 6.4. So I'm like, okay, that's helpful. Something to note, when you read through this, the cards, I don't know if you guys can see it, it's kind of small, but AMD cards internally, their IDs, they have a GFX number. So it's always GFX, then a number, and that's the internal ID of the chip. And so when looking at support, whether, does something support your card, will it run on your card, you got to make sure it has support for that GFX number, because the other branding names are kind of meaningless. So, yeah. So anyway, to summarize, why I'm doing this, and again, this is not necessarily a bad thing. AMD is supporting what they can support, but this is what happens. So basically, you have the official AMD binaries. If you find a problem and you're in the supported world and you report it, I've actually seen on some of their GitHub issues where they respond to a bug report saying an internal ticket has been opened, which is awesome. Hey, welcome. So if you're in that supported world, that's great. It's great that they are responsive. But if you're not, then you get the binary compatibility, support for newest cards. If you're open source, you're responsible for the problems, but you get to control binary compatibility, and you get to turn on and off cards. There are compiler flags to determine what architecture you're compiling for, and you get to avoid the problem of if you have an older card that's supported like an older version of ROCm, because AMD has pulled that code out, you can drop back, but will that older version of ROCm build on a newer Linux distro 5 to 10 years later? And so there is a certain amount of this in terms of, maybe avoiding e-waste. Not everyone has the option of buying the latest and greatest card for the latest and greatest distro, right? So it'd be nice, especially with, I actually have it running. I wasn't able to jam my big video card into this little system. It almost made it, but then it didn't. So I'm running it on the APU. So I'm literally going to be doing a little bit of OpenCL on the CPU embedded chip, which is not super fast, and hopefully I'm able to pull up the benchmarks so I have some of the numbers from my 7900 XT, which runs beautifully. Hopefully, I haven't compared it to other things, so for all I know, I compiled it wrong, but we'll see. So anyway, so what are my options? Roll my own, with the disclaimer that it may contain oregano. So be careful about that. Oops. So I mentioned before the elephant in the room, and that is the ROC. This is what they call their build system. It's github.com/ROCm/the ROC. And it is a CMake and Python amalgamation that wraps on top of the CMake build systems of all the different modules. So there's you set up a Python environment, it fetches dependencies. It also makes extensive use of Git submodules. And so it's very much tuned to, hey, we have you set what commit you want to pull out. So it's not a classic, dependency tree where you have a package with a pinned version and then you just kind of go from there. It's more run this script to fetch dependencies, go into a Python environment, create a CMake build environment, and it does this multi-process thing. It really bogs down a system. I have a 16-core or 8-core, 16-thread CPU with 32 gigabytes of RAM, and it basically chewed up everything because it tried to compile everything at once. It becomes very confusing to figure out what it's doing when it errors, which module error, because it's doing another one in the background. When compiling one of the modules, you have to be careful when you do multi-threaded builds, because I had one where it exited with an error, but the error was so far back it was beyond the buffer of the terminal. So I had to, probably put it in a log file somewhere. It's glitchy. I've had issues with the pinning where it says, oh, they have a help page. Hey, if you want to make sure you download a specific version or specific, Git. I think I started this before ROCm 7.0 was officially out, but it was pre-7. It didn't even work. It kept pulling in the default version. It's I followed the instructions that they have to specify which commit you want to pull, and it wouldn't do it. And the reason I needed to do that is because this year was GCC 15, right? So a lot of stuff doesn't compile on GCC 15, and ROCm was one of those things where there were a bunch of fixes they needed to do to make sure that these things would build. So I was in this weird state where I needed to pull in the newer stuff, but it kept wanting to grab the old one, and I'm manually patching it out. It was not fun. I think the last time I tried it, it also said it failed because it tried to sign something, and I don't know why it was trying to sign sign it with that person's key, but it gave me an error that I did not have the private key. Well, of course I don't have his private key. He's an AMD employee. Why is it doing that? And when I get too many issues, I just give up. I'm done. I'm moving on. I'm doing it myself. And I do have some package management experience in Slackware, building the Slack build scripts. And I'm looking at this, and it's they have the ROC thing does it, but each module that it does has its own build system. They all have a CMake set up individually. Sure, there's 30 of them, but it's not impossible. I've built Inkscape before. It wasn't fun, but it was doable. I don't know if anyone's here ever had to compile all the dependencies for Inkscape. It's it just goes on and on. But I think what they do is it's a C++ application, but it's just one. It's all the GNOME stuff, right? It just goes through all these really tiny libraries. Anyway, hopefully this doesn't upset anyone at AMD if they see this, but this is my understanding of how the ROC works. You at the bottom is where it starts, the low-level dependencies, and kind of a flow chart of how you build, the direction you build in until you finally get to your finished packages. You got to build a compiler, which offloads to the GPU, so you have to build LLVM and make sure it doesn't clash with your system, but you're also using your system compiler for some of the packages, so you have to make sure you keep track which ones use their compiler, which ones they're using the system, because that's going to matter. You've got a handful of external dependencies that you probably already have, but for whatever reason, the ROC wants to just grab stuff down, and some of them, this really concerned me. I don't know why they did this, but some of them, and I think one of them was a Google project, they're not using the dependency straight up. That they asked the maintainer of that, what was a logging thing or a performance tool or something. They created a branch in their GitHub repo for their library that was specifically for ROCm. So if you were to just go out, check out the master or main branch, you'd be getting a different thing. Like what? I don't know why we would need to do that. Just do the classic, pick a version. If you need to use an old version, use an old version. That's fine. But it was just weird. There's a bunch of CMake stuff that's aside. It's kind of strange because I don't know how much of it is. You can kind of get to. I've gone ahead and built it, but you can actually get to OpenCL runtime without some of their CMake dependencies. Like they have things that they build, and there's packages. There's a whole GitHub repo. But you don't really need it to get the OpenCL runtime running. But I think it's going to be important later on when I start doing the libraries. They have, however, simplified it. It used to be worse than this. So libraries and systems are now what they call mono repos. So they have aggregated a lot of their dependencies into 2 different sections. So systems is more of the foundational stuff to talk to the card. Libraries is mostly the HIP and actual machine learning stuff. It mostly lives in there. And there's actually now a central source of that. So you can kind of break it apart, which is nice. So that is an improvement in ROCm 7. It was a lot worse than this. And then ROCm goes on top of it, and then it goes there. Over there, that square off in the corner, handful of packages that have not yet been categorized. And I think one of them is RCCL, which is a communication library for multiple cards. Kind of important. I didn't realize it even existed until a CMake build script kicked an error. It's like, oh, okay, cool, it exists. And I, found it. It wasn't hard to find, but it didn't know it existed until CMake errored out. So a lot of this is, run the build system, see where it fails, and then just, Anyway, so here's the complete module list that I have put together of the stuff that has mostly been important for me. Some of this is taken from their mono repo. But basically, I've prefixed everything. I'm using, for toolchain and systems, I'm using my naming convention. So everything is namespace to keep them organized and separate. Because with LLVM, I just don't want to call it LLVM because it's going to clash with my system. But basically, these are most of what you would need. Haven't built libraries yet, working on it. But toolchain and systems are going to, and ROCm CLR, OpenCL runtime. That's the important one that I'll show you guys in a bit. And also SMI lib and ROCm info. Those are cool. Those are the NVIDIA SMI style tools. So now they do have a tool, and I think they're going to be renaming it as AMD SMI, but it is a tool where you can actually watch what your card is doing. You can see your usage, your memory consumption, and what processes are running on it, which is really cool for compute. So anyway, so package list. So here's the order that I build them in. The interesting thing about the way I figured this out, I didn't go full trial and error. I actually ran the rock, and when it failed, it spit out a bunch of log files because it was doing it simultaneously, and it had an order. There was actually date-stamped logs where it started doing the configuring and the building, so I could get a sense of how it starts. So now I have the initial tool chain. I build their CMake thing. I also build a specific version of CMake. So because I'm on, this will vary from distro to distro, but because I'm on Slackware 15, CMake is too old. Current, CMake is too new. You need to basically be newer than 3.21 and older than 4. So I had to build a specific version of CMake just for this. And then AMD LLVM, that is the beastly compile. That takes like 30 minutes. That is a compiler. And what's cool about that is that it actually has the low-level ability to compile code, C code that runs on the GPU. It's the offloading. That's an important one. Once you get that done, everything else is pretty fast. Device libs, HIPCC, and COMGR, or CO manager. It's communication object manager. Those are part of LLVM. I split them out. They're because they forked LLVM and they added some stuff. So I created separate packages so I have a little more control over it because they don't necessarily need to be installed. Actually, no. Device libs, HIPCC, and COMGR probably do need to be installed, but LLVM, once you get if you have an application, those are compile time dependencies. You can remove those and applications will still run, type of thing. So I'm going to be documenting that once I get everything built. I'm going to figure, okay, what do you actually need to have on your system? Because if you've ever looked at the packages for LLVM, like a full package, they're huge. That's nearly a gigabyte of disk space for something you'll never run. Then you have the systems, core. I swear, core is a one function library. I don't know what they're planning on doing with it. It's got a couple things to determine the version of ROCm that you have, but you can do it from within C. So it builds a really tiny library. Rock Profiler, that's in a state of flux, but they have a profiling system where you can actually monitor what's happening on your card. The ROCr runtime is a dependency for OpenCL. It's they have what they call HSA. I forget what that stands for. I could look it up in a minute, but that's like OpenCL and everything talk to the HSA library. There's layers to this. And then the SMI stuff, which is really easy. So anyway, yeah, and that came from the ROC. I just had to let the ROC do its programmatic thing with CMake to spit out log files, and then I'm like, oh, that's the order it's trying to build it in. And then things started to make sense, but I wish the ROC worked. I haven't tried it lately. I probably will again, but whatever. ROCm tools, when you're packaging like this, you sometimes will end up creating a package that is not part of the software. This is to, every distro that packages ROCm will need something like this. It's to set the environment variables, to make sure your path knows where it is, because you don't want this stuff clashing with your system. So everything goes in opt ROCm. And yeah, you just need to make sure LD config can find it, your profile is in your path. You want to be a little bit careful. You don't want to add everything because of the fact that it will overwrite. So LLVM is specifically not added. I need to make another script that allows me to set stuff before I try to compile, because since I already have LLVM, if I try to compile, it'll grab the wrong ones and it won't offload properly, right? But, anyway. And yeah, and I also wrote a custom script, CL config, to set my ICD file. I don't know if you guys haven't run OpenCL applications before, you'll probably noticed they tend to get confused about what card they're offloading to. Because by default you'll have like multiple ICDs in the vendor folder.
So what's ICD?
I don't know what that stands for. It's the vendor file. So it's the thing that tells, it's a text file that tells the application which library to talk to offload to the card. So you'll have an SO file that is the thing from the GPU vendor that contains whatever API. It has the same API, but it talks to a different card. It could be the CPU, it could be AMD, NVIDIA. Mesa has one. They always have like a set of default ones, but they're not great yet. Although they will be one day. So here's ROCm SMI. I think some of you saw it when I was fiddling with it, getting this thing going, but it's basically just a really cool, if you've used NVIDIA SMI, it's pretty much the same thing. This is the default output. It shows your temperatures, your clock speeds, your wattage, power consumption. So like this one was taken on my desktop. This was on the 7900 XT. You can see my power cap is 265 watts. It's a 265 watt card, but it's idling right now, so it's just sitting at 13 watts. So it's nice to know that that's working, right? And then my VRAM is at 6%, probably just because X is running with KDE, and then the GPU is just kind of sitting there at 5% usage. So that's cool. So anyway, getting to the end of the presentation here. I know that was a lot of data, just kind of running through, getting a package list, getting to go. I'm going to switch over into demonstration mode in a second here. Always remember to read the README, even when they're not well written. They usually have something. Each ROCm package has a README. And there were a lot of times where I'm sitting there like, why is this thing not compiling? And then, oh, it's in the README. These links, the one at the top is my set of build scripts. There's a main link to the ROCm GitHub, and then the ROC GitHub, if anyone is brave enough to try it on their system and see if, hey, maybe you get a different result than I do. Because it could very well be a Slackware specific thing. Who knows? You don't know until you try. Anyway, and they are putting a lot of effort, and to AMD's credit, they are trying to consolidate a lot of this because it was a mess in the 6.x series. With 7, it is a lot simpler. But I wanted to go through this and kind of get a minimal OpenCL build because I think when I was working with my dad and we have different cards of different ages, so he was actually just straight up telling me, well, I can't run ROCm 7 because it says it doesn't support my card. And I'm sitting there as I'm building ROCm for my card, I'm watching it build, and I was watching it output bytecode files for all the different GFX IDs. And I'm like, some of those are really old. So your card is in a list, and yet you've got a bytecode file. So what do they mean by support? So anyway, and this is where that comes into play. Oh, my mouse is in the way. Get out of there. So I want to start adding the ROCm libraries. So that I think is where the support comes in. I think if you're on an older card, you may not get the full machine learning stuff. I think is really what that comes down to. When they say, oh, features aren't going to work, that's probably what it is. But I'll show you guys the scripts in a second, but I want to go ahead, going forward, I'm going to be adding more stuff, updating my build script, and yeah, going like that. Hopefully, my hope is with these build scripts, if anyone's curious, if you're looking to build this for your thing, it's kind of Slackware specific, but it might be a little easier to look into what's going on instead of trying to read the CMake files. And so if you needed to make a build system to get this stuff going on a different distro, hopefully it's easier to read through this setup than theirs.
So what's OLAMA?
OLAMA, that's Meta's open source machine learning thing,
Gotcha.
Their LLM thing.
All the weights are open.
Yeah. So that's the model isn't, but the system something. I don't know. Well, that's what I want to find out because I can't run it, so I want to find out. So they are bragging with 7. They're like official OLAMA and PyTorch support. So whoa.
So they are bragging.
Hearing myself. So anyway, so the presentation will continue in a moment in show and tell land. Feel free to direct any angry questions, comments, and concerns to that address. And yeah, so no need to form a line. The server does that on its own. So anyway, any questions before I bust out the command prompt and start showing you stuff? Any questions so far about ROCm? Yes, no, maybe? Awesome. Let's do this. Let's do this. So I mentioned before that, so real quick, what this system is, because I mentioned I hadn't gotten to shove my graphics card in. So this is what I wanted to find out. When ROCm says they don't support, here's the limited support. Actually, I'll pull that page up real quick. Wherever they put it, wherever they stuck it. I'll have to find it. Oh, did I have it? I had it in the presentation. Let me find that real quick. Where was it? There it is. Oh, no, let's not do Falcon. Falcon's weird. Normally I would, but not the older one. Oh, paste and go. There we go. Okay, compatibility matrix. Let's check this out for a bit. Yeah, we'll accept your cookies. So here we go. So, operating systems and kernels, pretty basic architecture. This confused me for a while.
I have a question. So the version numbers up there, you scroll up a little bit.
Oop.
That's so 7 point, all that stuff isn't supported until 2404.3? Is that?
That's supported in. It is supported. That is the version of Ubuntu that they support with that version of ROCm.
Okay. So
And that's from 2 weeks ago.
Wouldn't work? Is that
There is no
what it
.2.
means? No.
Oh,
No.
that? Okay, now you're being picky. That is a question for AMD.
Okay.
That's just what they put in there.
Yeah.
So this is classic, a company releasing what they support.
So it's that one
Yeah.
specific thing you need that version.
I would assume it doesn't care.
Yeah.
This is whatever they wrote down at that time. A lot of this feels to me very much like a company wanting to limit their support scope and not have to deal with this. And then at the same time, they brag about how their build system and everything is open source. And I think the reason they brag about it being open source is so that if you're not on that table, you can go do it yourself.
Yeah.
And you don't have to bug them, right? And that I don't blame them for that. There are a lot of distros, right? However, that is weird, and as I scroll down, you'll start to see. So architecture is a little strange. So CDNA, RDNA type stuff. Internally, when it builds and it compiles files, they never actually distinguish between the CDNA and RDNA. So everything is a GFX number. And in fact, some of the folders it creates are AMD GCN, which is the older architecture. I forget what they call it now, but it's not GCN. And that was a confusion. So why is my card's bytecode file in the GCN folder? Well, because they didn't bother making another one. GPU LLVM target. So these are all codes. Most of these are recent. If you can tell here, I can do, let me make this a little bigger. There we go. So I have one of the things it builds is the...
One more.
One more?
Yeah. Oops.
There we go.
There you go. Thank you.
And I'll just go up here again. Sweet. So there's a tool it builds called the ROCm agent enumerator, which just spits out your GFX number of anything. And if you have multiple cards, it'll spit them all out. I'm GFX 902. So if you notice here, I don't see a 902 on this thing. So it's working to an extent. But yeah, and then framework support. So they actually put a lot of effort into reaching out to some of the major frameworks. But this is kind of, for me, being a support guy, my frustration is they're not differentiating between the different systems. They're treating ROCm as one big lump. And I know that there are a lot of people out here who probably have scientific computing applications that are just OpenCL, they don't necessarily need all that, right? They already have an application. A good example of this would be Hashcat if you're doing password cracking or something like that. Third-party stuff, blah, blah, blah. Driver. This is kind of irrelevant, the driver and user space. My understanding is that it's now in the kernel, so you don't have to care. ML and computer vision, all that stuff. So the composable kernel, I want to talk about that for a little bit. I don't know what it is. That is way over my head in terms of the computer science. All I know is that thing takes a long time to build. And I know one of the other Slackware guys who has his own style of building, he's been working on it, but he's having trouble maintaining it because it literally takes him 2 days for that one component. It's probably a consumer system, but it is a beefy compile that is not required for OpenCL. And I think that's an important distinction. I wish they would be a little more, and I think that's also why some distros have like an OpenCL thing, but they don't have that. And what that does, and part of the reason for that is it builds something that gets embedded into the application. It's the kernel to speed up. It's something that gets loaded into the memory of the card. It's very card specific. And so you have to build a kernel for like each architecture, each target card. And so there is actually, when you compile it, there's a AMD GPU targets variable. The more cards you specify, the longer it's going to take. So if you want compatibility with every card that it supports, you might be sitting there for a week compiling it. So anyway, and it's a dependency for a lot of machine learning stuff. And then, math libs. Here's this thing. So you notice, fun fact. So you see the HIP, they actually normalize their naming conventions. It's HIP and then there's ROC. ROC doesn't stand for anything. It's just, for legacy. But this is where things get interesting in terms of having all the dependencies. The HIP libraries actually talk to the ROC ones, ROC. That's why they got the same names a lot of times. However, they can also link to the CUDA version. And so if you write your application using the HIP library, you can run it on an NVIDIA card. And so this gives, I think what AMD wants to do is make sure that people can use what card they want, avoid the vendor lock-in. So I'm kind of thinking of HIP as like their version of CUDA kind of thing. You code for CUDA, everything magically works, or HIP in this case. So anyway, math libs and the usual stuff. So this I'll leave the computer science nerds to figure out how they actually use that stuff. It's one of those, if you know what it is, great. I just want to make sure it gets built. System management tools, AMD SMI, that just got renamed, so they have both here for some reason. Why, I don't know, because I think they're getting rid of, according to the repo for ROCm SMI, they're getting rid of it. Some performance stuff. I'm still going through trying to figure out how much of this is actually necessary. Development tools, blah, 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 compilers. Yeah, fun stuff. And then, the footnotes. So yeah, this is what I was talking about earlier, about the confusion about what's supported and why I want to dive into it. A lot of stuff here. Let's see if I can find it. They got a lot of stuff. Rocky Linux 9 is only supported on AMD Instinct card GPUs, the data center ones or the machine learning ones. This guy right here. That kind of freaked me out. Like, why can't you run all the cards on Rocky 9? I don't know what they're trying to say with that. I don't know what that means. But it almost sounds to me, and this is the concept of binary compatibility, it almost sounds like when they built it for Rocky 9, they specified the AMD GPU flags to only build for those cards. That's how I read that.
I'm gonna guess there's one cloud provider that only gives you that card.
Maybe, yeah, that you might be right there. I hadn't thought about that. But, and the thing is, and so it would make sense then if it's cloud. That was why they want to keep the file size down, because the composable kernel and some of the other modules, they're card specific. They're huge. I mean, you will chew up a couple 100 gigabytes of space if you try to build everything. You could easily hit a terabyte, I think, if you try to do every card. One of these days I'll actually try it and see what happens. But so that would, by doing only 2 GPUs, that keeps the file size down, the compile time down. But that also means it's like, if I'm on Rocky 9, do I get to use my card, right? And a lot of the earlier stuff, the LLVM and whatnot, it's not a lot of space. It actually is fine to build everything. I'm not specifying in my scripts yet because I don't need to, because it's fine, just build everything. They're little tiny files for bytecodes and whatever. So I just let it. And they got the same thing as you continue going down. It's just the same kind of like this guy right here is only supported on this version. And like you said, is that point release, Matt? Does that matter?
Yeah.
And it actually might No, it shouldn't, because they don't do a driver module anymore. There's no AMD GPU replacement. It used to be that they had there was the AMD GPU replacement module, but now there's not. So I don't know. I don't know what this. So yeah. So anyway, I'm just gonna oh look, there we go. That maybe this will answer your question. The glibc versions and stuff. So yeah, I mean, so yeah, it supports back to kernel 5.14, which is kind of nice. So they do have a lot of backwards compatibility. They have some people running it on newer kernels somewhere. Oh, 6.1, 6.8. So yeah, I've now successfully run it on 6.8.16 with glibc 2.42. So that's been working fine. Yeah, past versions, blah blah blah. The other thing though is this. Again, I'm a stickler for this. The extended platform support. First of all, it doesn't say 7, it says 6.44. So I'm like, is this even up to date? But even though it's the older version, notice how it doesn't mention anything before the 7000 series. So where are my 6000 series cards? Where are my 5000 series cards? And even before that, we know they can work. I remember you were crunching on an RX 590 for a while. You were running OpenCL with an older version. You got it built, and it was working. So, like, I would understand saying it's not. You don't want to say fully supported, but not even listed. Like their compatibility matrices leave a lot of questions. So, it would be nice if I could just run. I'm of the opinion if I could just run their build system and I'd be happy, I'd be fine. But even then, I want to understand what is supported, what works, and go from there, and maybe document it myself. It is open source, so hey, if I figure it out and I document it, maybe they'll take a patch, But anyway, so yeah, and if you want to dive into the OpenCL stuff, they have a whole thing here. You click on this link, and this is basically their section on GitHub, their page or whatever. They currently have 349 repositories. Some of those are, like if I go to this one, you'll see a lot of this. This repository is retired. Please use ROCm/ROCm-systems repository for development. This branch, it's retired, but it still gets updates. They're pulling stuff over from the other. They're like, I don't know how they do that in Git, but they're pulling, it has all the updates. I don't know when they're gonna cut that off, but you'll see a lot of this where a repository has been retired and it's somewhere else, and there's a lot of back and forth. But if you click on this, go here, this is kind of the structure they're moving to. Under ROCm systems, you'll see here they've got, is it compiling? They got stuff that doesn't compile, failing on Red Hat, blah, blah, blah. But then you go into projects, and you can see all of the stuff that they consider part of ROCm-systems. And this makes it easier to build for your distribution for package management. So I kind of continued that. So over here, I have a similar thing. So I have, under modules, I'll do a similar thing. Here's the initial ones, the important ones that have to start, LLVM, CMake, whatever. And then I've got systems. And I just a lot of this was just set up. I create a folder from their thing, put in my scripts, and go. And building these is not particularly difficult. I can just open one up here. It's a shell script, and it just, does some setup for file names, architecture stuff. And a lot of this is Slackware specific, so I'm gonna skip over it. But then you get to the big CMake command. Notice how I'm doing opt ROCm's bin CMake because I gotta use my version, not whatever my system has. It has to make sure it grabs everything right. And then just specify stuff. Yeah, so it's kind of cool. It takes a while to get. It's one of those things when you have a lot of packages you're building that are part of a set. It's slow to get started, and then it speeds up dramatically because you now have a pattern, and you just repeat that over and over. And I think it's a lot, for me, it makes a lot more sense to do it that way. There's more upfront effort. Whereas something like doing what I think they're doing was probably very quick to set up. They're having CMake figure it all out. They just add lines in CMake to say pull in this project. But over time, I think it got really messy. And now it's just erroring out right and left. So, or at least for me. I'm sure that they've got a new Ubuntu system or a Red Hat system somewhere that builds it just fine. But there are a couple hundred, I don't know, how many distros do we have, do we think, for desktop? I know DistroWatch still has their top 100, but there's a lot of distros out there with different styles. So anyway, over here, so ROCm, this is where things get cool. So I'm gonna do ROCm-SMI, and if you do -A, you can, oh, I'm gonna do less, do it to less. There we go. So ROCm, this is kind of cool because we never really had this on AMD. They spit out a lot of stuff. So this is what's running on this APU right here. It's important to note, and I've noticed this in NVIDIA as well, consumer class cards don't have the full range of reporting, so a lot of stuff shows up as unsupported. Some of that might be bugs in the driver. Some of that might just be the card doesn't have it. But you can see your temperature, your BIOS version, all that stuff. I think Cezanne, is like my CPU's code name or something because it's part of the CPU. Performance levels, all that stuff. Power cap, it can't for this one. It can do it for my 7900, but it can't for this one because it's tied to the CPU. Your profile modes. I noticed power profiles. My main system that has a dedicated card doesn't switch power profiles properly. This one is. This one when I was doing compute, it was switching over. And then your supported frequencies, blah blah blah. This one's relatively simple. And yeah, all kinds of cool stuff. Error when calling libdROCm. Yeah, that might be me. I'll have to check. I'll have to look at that, see why it's because that doesn't happen on my other system. So a lot of linking stuff. You also have ROCm info, which gets really into it. So this is a much lower level view of your card. And this is, if anyone here is into the low-level computer science of processing and whatnot, this is where it starts to get really interesting. Way over my head, but it's nice that it puts it out. So it says your HSA agents. So these are your compute targets. One of them is the CPU, and it gives 16 compute units on the CPU. That's where that comes from, and also other things for things like bandwidth. Let's see. Oh, there it is. GFX 90C. And if I go down, you start to see stuff for like grid size. So you have, with GPUs, you see this with video games sometimes, texture sizes matter, right? The GPU is optimized for certain texture sizes, and the same applies for compute. So anyway, cool stuff. So now you can see all that info. Blah, 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 blah. So anyway, who wants to see it run something? So I'm gonna go over here. Sorry. I've been doing this, I've been getting all excited about this stuff for a while, but it's so happy that it's done. Okay, I'm gonna pull this guy up. So, let me zoom this in. So I'm gonna do ROCm SMI -u -show mem use, and then -show PIDs, I think. Yeah, okay, cool. Actually, I'm gonna shrink it a little bit. If that's too small, let me know, but it's
okay.
Mostly for monitoring. So what I'm gonna do, I'm gonna do watch. And I'm going to do, let's do every 0.5 seconds, which might be a bit excessive, but no, let's go. So this is just running in the background. So every 0.5 seconds, it's going to query the GPU and do that. So what I can do over here, if I go Phoronix test suite, and I'm going to just run I was doing this earlier today, so it should be fine. OpenCL benchmark should still be there. And I'm not going to save it. So this actually takes a while to run, but pops right up. So now I can see that I got a PID running on it. I can see how many compute units it's using. My GPU usage just hit 99%. So I'm actually now running an OpenCL process on this card, or on this chip. It's running very slowly. I think this one takes a while. There's 3 runs, and it goes for a while. My desktop is a lot faster. So let me pull up, while that runs, just for giggles, let's pull up this, and I'm gonna go, I wonder if it'll let me do this right now. Test suite, what is the option here? Show results.
Show result.
Yes.
If you do it without any commands, it'll show you all the results and then you pick one.
Yes, ROCm. So this should have results not just from this system, but also from my desktop, which has an actual card. Blah, 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 blah. Yes. Hooray! Okay, cool. So scroll down. So this is, this thing renders so weird. Good God. It's like it's designed to be embedded into his website. So very different systems. I'm running a much newer operating system, because I have to. For that card, I have to run the newer one because I need the driver. 15.0, I think, came out before 7000 series came out. So it's a very much an apples to apples thing, but it's more to compare performance. The fact that it's running a dedicated card versus an iGPU is kind of, a thing. It's already going to be just a wipeout. But if I scroll down here, this was for Hashcat. So you can see my hashes per second for like MD5. It's definitely beating it. And I've noticed, and this is a thing, so while you can, there's going to be a component to compute. Just because you can doesn't mean you should. I've noticed some stability issues with running Hashcat on the iGPUs. It doesn't like to. It's very inconsistent. I'm not going to do a demonstration of Hashcat here because it takes forever, because Phoronix Test Suite gets confused because it gets weird responses and then runs it like 15 times when it should only do 3. This guy. Yeah, this is on the second one. This one works. The benchmark is fine. But, yeah, and so you can see, SHA, some of it doesn't work. So I got to figure out, why is it not doing 7-zip? Am I missing something? I don't know what that error is. Why is it looking at that? I don't know why it's looking in my sys folder. But anyway, so I got to do all these things, but basic functionality is there. 250 SHA 256, blah blah blah, and then 512. What I kind of want to do is set up a dual boot on my desktop for one of the supported Ubuntu versions, install it their official style, and see what my numbers are compared to theirs, in case I'm missing something. Because for all I know, I'm compiling it in a horrible way. That's I could have done something horribly wrong. So I kind of want to do a comparison. So this is the beginning of that. But right now, it's mostly just to show that it's working, right? But if I close this out, can I? Oh, god damn it! Stop it. There. So the other one was plug OpenCL benchmark. This is just a generic, I think this is from like a physics thing or something. It's just on Phoronix. It's one of their benchmarking modules. It's still running over there, 87 compute units. Or 87%. Maybe that's a percentage, because I don't have 87 compute units. I know I don't. It only has 8. What? Yes. I said yes. So. Let's see what we've got here. So there we go for floating point 64. There's the results. There's the teraflops per second for the 7900 XT, and then for this, whatever this is. It doesn't have a name. I think it's Vega or something. It's just, actually, out of curiosity, this thing, Control C. User sbin. Come on, plus PCI. God damn it. Don't make me SU to root. I will. Grep VGA. So that's basically what my card is here. It's not even a card. I don't know what that's supposed to be. it's just embedded in the CPU, so they don't really have names when they have the onboard ones. So it's obviously not going to be great for compute, but the fact that it's there and that it's working, I think is very interesting. I think depending on the application, if this is an accelerator option, right, why not have it available? So anyway, that's kind of where I'm at for the project. So I'm going to be adding, I don't know how soon, but I want to get into the machine learning stuff and get that built, and then see if I can run PyTorch or something, and do some image recognition or image generation or something. There's also OpenMP for offloading to the GPU, which isn't really machine learning. It's just, so there's a lot of options. So I got to go through, build that. But now that I'm getting started, just roll through that. I hope if anyone wants to check out the repo and see if those build scripts help you build it for your favorite distro, go for it, right? Or just for fun. It's a learning exercise a lot of times. And maybe I'll do a comparison and see how I go against Ubuntu. I'll let you guys know on the list if I'm either blowing Ubuntu out of the water or getting my ass kicked. So, so that's that. Is this thing done? Actually, did it finish? I think nope. Oh, it did. There we go. Yeah. So for these, yeah, so it ran through a bunch of tests, completed them successfully, and really low numbers. But yeah, so benchmarking is only as good as what you're comparing to, but so it's kind of proof of concept of running it. Because if you try to do this by default, it's not going to work. Oh, the one thing I want to show you guys, and this is important, if you ever do OpenCL stuff, I don't know how other distros manage this, if it's the same thing everywhere, but if you look at your ls -l, so when an OpenCL application runs, it looks for an ICD file, and maybe I should Google that acronym. But it's usually in the etc OpenCL folder, and then there's a vendors folder. And you'll notice mine looks a little weird. I have a default.icd link. Doesn't usually look like that. The inactive vendors, that I created that manually. Normally you have all your ICD vendors here, and so an application can then choose which target it wants to go to, right? For whatever reason, all the applications I've run into other than the ones on Boink are incredibly stupid programs that will grab alphabetically, and a lot of times they grab one that glitches out. And if you have multiple in here, I've seen CL info like give weird responses.
ICD is installable client driver.
Okay, yeah. So what these are, so if I like cat, let's see, let me CD to that. So if I CD here, right? And so if I cat defaults, oops. I would assume other distros do things. So it's a text file and it just contains one line. It's just the name of the library or a path optionally. If I look at inactive, I have, I think that Mesa one's old, now that I think about it.
Well, the Mesa one that comes with Mesa, that's OpenCL 1.0.
But did it go away in current? Did they phase it out? Not yet?
No, Mesa hasn't.
Oh, God damn it, what'd I do?
Working on Rustical.
Yeah. I can't believe you keep calling it Rustical. I can't stand that name. So yeah, same thing, and then the Rust ICL. And the way, if you ever want to test, oops, nope, that didn't work. Oh, I don't have it in there. Oh, this is because this is 15, so it doesn't have, okay, yeah. So yeah, if you're on a newer distro, you'll have a Rust ICL, which is the new one written in Rust. But the way you know that these are working is you do CL info -- list, and it spits out your OpenCL platforms. If you have multiple files in here, it will work, but I have seen situations where OpenCL, when it tries to link in those libraries, if there's a compatibility issue, sometimes it seg faults. And if you're getting seg faults, that means you probably have too many ICDs trying to clash or whatever. And if you run it without the list, CL info just prints out all the debug information for that platform, everything that it can do, all its stuff, yeah, extensions, compiler stuff. And platform name is AMD Accelerated Processing. I ended up writing a script, and there's a lot of Slackware scripts that have this style. So I hope someone doesn't get mad at me for copying it. But CL config, which basically pops up a little dialog, and this can be run as part of, I could have this as part of the package installer. When it runs, it immediately pops this up so I can select it. But what it does, it lets me choose which one is there and does that link. So that way I don't have to worry about applications getting confused and picking the wrong one. Because I have had situations when I first started doing some of the compute stuff where, and I think even when I was on NVIDIA, this was a problem where you have their version of it, their ICD, but it grabs the Mesa one, which didn't work with NVIDIA, and it was just like, why is Phoronix freaking out? Why is Hashcat not running? And it's just because I think Hashcat in particular is extremely dumb. I don't know, like it just picks one in the list. And I've read through the API documentation for how you're supposed to do it, and a lot of it, there are examples and demos of like, okay, here's how you initialize the engine and iterate through available engines or platforms to pick one, and you're supposed to pick one. And I think some people grab that example, grab the first one on the list or the last one on the list, and then run with it, which probably shouldn't be doing. But if you're doing Boink, those things are usually smart enough. They actually do grab the one, if you can have multiple, but sometimes it's best to have a system configuration tool to avoid that possibility. So yeah, so like I do this, right, and then, oh, it got weird. And then yeah, so now it points to the other one, it points to the Mesa one. So, just something just a little quality of life thing that I put in there to help with that. I would assume other distros have their version of that. However, that also ties into, though, in case, and this is not compute related, if you've ever gotten done with library installation, if you've ever done any kind of package management or configuration, LD config, which handles where libraries live, you'll notice those ICD files did not specify a path. And so how does it know where to get it? Well, that's where ld.so.conf comes into play. So over in here, etc ld.soconf.d, oops, I have a ROCm thing. Yeah, so it just specifies the path. Then when ld-config runs, whenever that runs, I have it set. I actually put in the package. It installs this file, and then the do install, which they call it. It's like where you would do this for Debian. It's like their post install script. You would just have it run ld-config. It'll add that path, and then all those libraries are now available. I also actually have one for GCC 14. I wanted to build something, and I had to do GCC 14, and it needed those libraries had to be in there. But so yeah, stuff like that is also important. And it's not unique to ROCm, but it's when you're doing a lot of libraries, you're going to have to do stuff. The one thing I haven't done is set up a development environment script, which is a script you'd run before you run a compile, before you run CMake. You probably want to run a script that just brute forces all your variables. It changes your path, changes your LD library path, and everything just to make sure it works. So anyway, last thing, and I mentioned this before, HIP. So that was OpenCL. I have the support for HIP. You can't do anything with it because you don't have any libraries, but you do have the HIP compiler. So if I do HIP config, it should, yes, it did. HIP config is the tool that basically gives you details about your compiler for HIP. So HIPCC is a program that is a front end to their version of Clang that sets it all up, makes sure that it compiles to the right output target, it goes to the GPU and whatever. So you can see when I compiled it, I didn't specify x86, so it compiled for my processor. So it's Zen version 3, so I don't know how portable this is. But yeah, so it's a whole world of environment variables to compile apps for a GPU. And so once I get it going and I can actually run it, once I get the full stack, I kind of want to go dig into it and see, okay, once it's built, how much of this do I actually need? Like, does it execute? Because I think that's the side that I'm not seeing in the ROCm world. They're talking about, oh, it's great, you can build it and deploy it. Well, okay, what if you're just a user and you just want to run the app? How much of this do you actually need, right? And there's not a lot of clarity on what that is. So anyway, so that's that. I don't have anything else, unless someone wants to see a demo HIP. If someone's feeling adventurous, I don't know if we have time, I can try and build one of the HIP examples. There is a Hello World example. I did it on my other computer. I don't know if I'll be able to do it here, if someone really wants to see that process. But otherwise, any questions?